Question 1. A student wants to separate, so this is separation technique, a mixture of dyes, so that we can identify the dyes in the mixture. So this is definitely paper chromatography technique, and this comes under the separation technique in the Cambridge curriculum, as well as any 14 to 16 years old chemistry curriculum, to be honest. There are 4 different dyes, A, B, C, and D. So it's a mixture of dyes at this spot, and here's just pure A, here's pure B, pure C, and pure D. Baseline is what you draw with pencil, because pencil will be made of graphite, and graphite will not be separated with the ink, and therefore we use graphite to draw the baseline. We have a lid to prevent the solvent from escaping, especially if you have a low boiling point solvent or something which is volatile, means low boiling point solvent. This is the filter paper itself. After the chromatography itself, the filter paper is what you call a chromatogram. You support it on a lid that is keeping the beaker itself closed, and there's immediately something wrong with this chromatogram, because your baseline must always be above the solvent level. So this is a solvent level which is above the baseline, and that means your mixture of dyes actually gets into the solvent, and they will dissolve in the solvent, and that means you have the mixture inside the solvent, which will move the spot up, but it will also be separated into different spots, because even though this is pure, your solvent has dissolved the solute into the solvent, and you will have mixture of the dyes in the solvent that move up. Okay, that's why it's important to keep the baseline above the solvent. So name the process. So this is paper chromatography, so make sure you can spell properly. Like I said, this is a very time-intensive paper because it doesn't involve doing, it mostly involves quickly reading the questions. That's why it's important to circle, underline, scribble. Whatever you do to the question itself doesn't matter, because the examiners will just be marking whatever that you write down as the answer in the answer section. So do not waste time and rub out whatever you have written down or scribbled down, because those essentially are what you would use to brainstorm ideas, as well as for you to check back your work later on, rather than having to think from the very beginning again if you didn't write down anything. The apparatus shown is set up incorrectly, as I mentioned. So the baseline must be, what did they want? Explain why. So they want you to explain the mistake. Okay, they didn't say explain what you should do. So the baseline is incorrectly placed. Maybe I should say the baseline should be above. The baseline should be, not should be, must be, because must be above the solvent level. Otherwise, as I mentioned, otherwise the solute of the dyes would just dissolve in the solvent, and they would contaminate, or they will affect the chromatogram later on. So now the apparatus is set up correctly, which means if you didn't know what was wrong, you could just compare. Oh, actually you couldn't, because they didn't show you the solvent level here. Alright, anyway, you set up correctly now. Solvent travels up, paper is removed, the chromatogram is then dried. You get this result. Which of the dyes are present in the mixture of dyes? So this is the mixture of dyes. So I hope you can see horizontally there is A, so that it contains A, and that is not a very good line. Maybe this is better. Maybe this is, yeah, I think that will do. Okay, cool. So the mixture of dye also contains, oops, sorry, not B, it contains C. All right, and it also contains B, but it does not contain D, because there's no spot here. It does not contain D. So which of the dyes are present? In fact, they kind of give it away. Okay, so it's just A, B, and C. The student identified the dyes using RF value. RF stands for retention factor. I'm not sure if you actually have been taught on that. Doesn't matter. Retention factor, RF, basically means how far from the baseline has the solute traveled relative to how far the solvent has traveled. So I'm doing this on my screen So on an actual paper which is printed in A4, it'll be different from the landscape thing as shown on this screen. If you're watching this on TV, or on your computer screen, or on your mobile phone screen, it's gonna be different, but the ratio itself will be the same whether you're doing it on paper, whether you're watching this on screen, or if I'm doing this on my screen. As I mentioned, the ratio will be the same. So do not be surprised that the measurement that I'm doing is not exactly equal to what you expect. So I got that to be 6.5 on my screen. So this is 6.5 cm on my screen. From there to there. So from the baseline to the solvent one on my screen, it reads 6.5 cm, but it will be slightly different from what you will get on a piece of paper. Just be aware of that, yeah. Baseline and the position of A. So so that shows 1.6 cm. So that thing there shows me 1.6 cm. But again, that is just on my screen. So the RF value of A is how far A has moved compared to how far the solvent has moved. Put that into a calculator. 1.6 divided by 6.5, I get 0.246. These were two significant figure, 1 2 1 2. I will write to 3 before I run it up to 2 significant figure, and there are no units because this is cm divided by cm. All you get, RF is a ratio, RF is a value, RF does not have any units.